Hi everyone, good morning. I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this present video, I would like to discuss the question bank of Module 5. The topic is Vector Integration, Part B, second video. And in this video, I would like to perform some problems related to vector integration. So in vector integration, we have three models. One is line integral, and second one is surface integral, and other one is volume integral. And also we have three theorems: Green's theorem, Gauss divergence theorem, and Stokes theorem. So now I'm coming to the problem 1. If f bar is any vector point function, f bar is given as 5xy minus 6x square into I bar plus 2y minus 4x into j bar. Then evaluate line integral f bar dot dr bar along the curve C, y is equal to x cube from the point 1, 1, 2, 8. You have to evaluate the line integral along the curve y is equal to x cube from 1, 1, 2, 1, 1 to 2, 8, right? So what is dr bar? Dr bar is dxi bar plus dyj bar, because the curve is defined in xy plane, so it does not contain any z term. If it is z also there, then dz into k bar. Then what is f bar into dot dr bar? F bar dot dr bar. So the dot product of these two, that is 5xy minus 6x square I bar, dot product with dxi bar, that will be 5xy minus 6x square dx plus 2y minus 4x dy. So j bar dot j bar 1, I bar dot j bar 0, and j bar dot j bar 1, I bar dot I bar 1, like that. So in this way you will get f bar dot dr bar is this. Now I want to evaluate integral f bar dot dr bar along the curve C, that is y is equal to x cube. So the points also given from 1, 1, 2, 2, 8. That is integral, what is f bar dot dr bar? 5xy minus 6x square of dx plus 2y minus 4x of dy along the curve y is equal to x cube. So here y is equal to x cube is the given curve. Given the curve is y is equal to x cube, then on differentiating dy is equal to 3x square dx. And all the terms can be written in terms of, so now integral f bar dot dr bar will be integral, so I replace y by x cube, 5x into y means x cube, I am converting all the terms in the terms of x, minus 6x square as it is of dx, minus plus 2 into y, that means 2x cube, 2 into y means x cube, minus 4x into dy. Dy can be written as 3x square dx, or I can write from 1, 1, 2, 8, or I can write this is 5x power 4 minus 6x square plus 2x cube into 3x square, 6x power 5 minus 4 3s are 12x cube of dx. And here the x limit 1, 1, what are the limits? 2, 8. So here if you consider x limit, this is 1 to 2, x is 1 to 2, because all the functions change it into the terms of x. So the limit also considered from x1, y1, x2, y2, x1 to x2, that is 1 to 2. Now on integrating both sides, integral 5x power 4 dx, that is 5x power 5, 5x power 5 by 5 minus 6x cubed by 3 plus 6x power 6 by 6 minus 12x power 4 by 4 between 1 and 2. So 5 cancel. So the value is 2 power 5 upper limit minus 3 2's, 2 into 2 cube, 6 cancel, 2 power 6 minus 3 into 2 power 4 and lower limit minus 5 plus 2 minus 5 minus of minus plus 2 and this is minus 1 and this is plus 3. So I'm simplifying all the values. 2 power 5, 32 minus 2 cube means 8, 8 to the 16 plus 2 power 6, 64. 2 power 4 is 16, 2 power 5, 32, 2 power 6, 64 minus 2 power 4 into 3, 48 minus 5 plus 2 minus 1 plus 3. So simplifying 32, 64, 96, 98 plus 3, 101, 101 minus 16 plus 48. So this is 50, 48 plus 16, 64, am I right? 58 plus 6, 64, 64 plus 5, 69, 70, minus 70. So this is equal to 31 is the required solution of the given line integral. 101 minus 70, that is equal to 31, right? So this is the evaluation of line integral along the curve cy is equal to x cube from 1, 1 to 2, 8. So now on coming to the another problem, evaluate the line integral over c x square plus xy dx plus x square plus y square dy, where c is the square formed by the lines x is equal to plus 1, x is equal to minus 1 and y is equal to plus 1 and y is equal to minus 1. So here also you have to evaluate the line integral. Already it is given f bar dot dr bar, and here you have to identify the region, the lines x is equal to plus 1. This is x is equal to plus 1 line, x is equal to 1 and x is equal to minus 1. This is y-axis means x0, it is x is equal to 1, this is x is equal to minus 1. Similarly, y is equal to 1, this is the line y is equal to 1 and this is y is equal to, this is y is equal to minus 1 and this is y is equal to plus 1. So you have to evaluate the line integral over cx square plus xy dx plus x square plus y square dy along the curve, along the lines x is equal to plus 1, x is equal to minus 1. You have to go around this entire square. So in this way, in this I will first write integral f bar dot dr bar, already given it as integral x square plus xy dx plus x square plus y square of dy. So already it has given. Now along the I am assuming that this is x is equal to, this is y is equal to minus 1 line. This is y is equal to minus 1, this is equal to y is equal to plus 1, this is x is equal to minus 1, this is x is equal to plus 1. Now I evaluate along these 4 lines. Now I take first along y is equal to minus 1, case 1, along y is equal to minus 1. This is y is equal to minus 1, right? Then dy is equal to 0. Y is equal to minus 1 means dy is equal to 0. But here x is a variable factor. X is varying from minus 1 to plus 1. x varying from -1 to +1. So now in this along, suppose if I assume along AB, this f bar dot dr bar is equal to integral x value x square plus x into -1 of dx, and second term entire term 0, and here x -1 to +1, or -1 to +1 x square minus x dx. So what is the integration? X square integration x cubed by 3 minus x integration x square by 2 between -1 and +1. Or I can write it as 1 by 3 minus 1 by 2 and minus of minus plus 1 by 3 and minus of minus, here minus already plus 1 by 2 x. If you replace -1 whole square plus 1 by 2, and it is plus 1 by 2, these two gets cancelled. 1 by 3 plus 1 by 3, 2 by 3, call this is equation number 1. The evaluation of line integral along this line is 2 by 3. Similarly, along BC, now case 2, along BC. What is BC equation? The BC equation is this is x is equal to 1. The line equation is x is equal to 1. Along BC, the equation is x is equal to 1. So dx is equal to 0. But y varies from -1 to +1. -1 to +1. Therefore, integral f bar dot dr bar is equal to integral. What is the value? X square plus xy dx plus x square plus y square of dy. So dx 0 means this entire term 0. x1 means 1 plus y square of dy between y -1 to +1. So x1 dx 0. So the entire term, first term will be 0. Now the integration, integral dx x, and what is y square? Integral dy y plus y cube by 3. This is -1 to +1. So the value 1 plus 1 by 3 -1 -1 by 3. So clearly this is 0. This is the second part of the solution. Similarly, along CD. What is the equation of CD? This is CD. The equation CD is y is equal to 1 line. The equation of CD is y is equal to 1. So what will be dy? Dy is equal to 0. But here x is a varying factor. X varies from 1 to -1. 1 to -1. X varies from 1 to -1. Therefore, integral f bar dot dr bar is integral x square plus x, y is 1, dx. The second term is entire 0, and x varies from 1 to -1. So here dy 0, this entire term 0. Only x term will get the solution dx, x into y1, x square plus x of dx. That is 1 to -1 of x square plus x of dx, or an integrating x cubed by 3 plus x square by 2 between 1 and -1. So in substituting the upper limit, -1 by 3 plus 1 by 2 minus 1 by 3 minus 1 by 2. These two gets cancelled, and this value is minus, minus 2 by 3. So here see this integral 1 to minus 1, because we are taking in the anti-clockwise direction. 1 to minus 1 x square plus x of dx, that is x square plus x of dx, because y0 there is no second term in this, and x square integration x cube by 3 and x integration x square by 2 between 1 and minus 1. On substituting the upper limit minus 1 by 3 plus minus 1 whole square 1 by 2, and it is minus 1 by 3 minus 1 by 2. So the resultant is 1 by 2, 1 by 2 gets cancelled, minus 2 by 3 is the resultant. Similarly, you do the last integration along dA. Along dA. What is the equation of dA? dA equation is x is equal to minus 1. Equation of dA is x is equal to minus 1. So dx is equal to 0. But y is a variable factor. Y varies from this is 1 to minus 1. Y varies from 1 to minus 1. Therefore, integral f bar dot dr bar is equal to integral x square plus xy of dx plus x square plus y square of dy. X square plus y square of dy. This is integral x minus 1 dx 0, that is first term entire term 0, and second term you can see that x minus 1, that means minus 1 whole square, that is 1 plus y square into dy. That is integral dy y square integration y cube by 3, and limits y limits. What are the y limits? 1 to minus 1. 1 to minus 1. So 1 to minus 1. Or it is minus 1 by 3 minus 1 upper limit y minus 1 by 3, lower limit minus 1 by 3. That is minus 2 by 3, or minus 2 by 3, or minus 6 2 minus 8 by 3. Therefore, integral f bar dot dr bar is equal to integral along AB, along BC, plus along CA, plus along AD. So what is along AB? The line integral already we have evaluated. The line integral along AB is equal to 2 by 3. Second one 0. 2 by 3 plus 0. Next, along CD, minus 2 by 3, and it is minus 2 by 3, and this is minus 8 by 3. So 2 by 3 minus 2 by 3 gets cancelled. The resultant is minus 8 by 3, which is the required result for the given line integral. So these two are related to the line integral problems, and I will discuss one more problem. You do at your own. Just I will give the picturization of the next problem, and you are supposed to solve at your own. I will give the complete information regarding that. You try to solve this one. I will give complete explanation of this problem, and try to do this problem. Evaluate integral a bar dot n cap into ds, where a bar is equal to this one, and s is the surface of the cylinder. X square plus y square plus z square is equal to 16, included in the first octane between z is equal to 0 and z is equal to 5. So I will give the picturization of this curve. So this is the picture: x-axis, y-axis, z-axis, and x square plus y square is equal to 16. Suppose if you continue this, it will be a circle. X square plus y square is equal to 16. This is the circle. And here z is equal to 0, because it is in xy plane, z is equal to 0, and upper limit z is equal to 5. So what you have to calculate here is, you have to evaluate first the integral a bar dot n cap into ds, where a bar dot n cap into ds is along the surface of the cylinder. First octant. First octant means you have to find this and this integral a bar dot n cap into ds over the surface S is equal to integral over the this one OAB and this is CDE along AB along ABED. What you will get? The outward normal vector will be the surface. What is the surface? X square plus y square is equal to 16. This is the surface x square plus y square is equal to 16. Then you find the grad phi. Grad phi is the unit outward normal vector. Then grad phi by magnitude of grad phi. Normal vector, then grad phi by magnitude. Suppose if it is x square plus y square minus 16 is equal to 0. Then what is grad phi? It is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of x square plus y square minus 16. That is 2x I bar plus 2y j bar. That is grad phi. Then grad phi by unit outward n cap, that is grad phi by magnitude of grad phi. Unit outward normal vector. So grad phi is 2x I bar plus 2y j bar, the dot product square root of 4x square plus 4y square. So this is equal to 2x I bar plus 2y j bar by, I'm taking out 4 outside 2 and x square plus y square, what you will get is 16. So 2 is cancelled and xi bar, what you will get in the numerator, xi bar plus yj bar by root 16 is 4. This is the unit outward normal vector for the surface ABCD. For the surface ABCD, the outward normal vector is this. So this, keep this outward normal vector is n cap. And for this surface, the outward normal vector is in the direction of z, that is k bar. In this direction, minus k bar. So using these three, you find outward normal vector is already there and a bar there, a bar dot n cap. And you have to study three cases. Case 1 is along the surface ABCD and along the surface ABE, OAB, the outward normal vector is along the direction of z, that is k bar is the outward normal vector. And for the surface CDE, the outward normal vector will be the minus k bar. So using these, we find three cases. In each case, a bar is common and n cap will be different for the given problem. And then you add all the three, then you will get the solution. So with the few words, I conclude my session for this vector integration. And this was taken from question bank of the course Differential Equations and Vector Calculus of the regulations BT 23 published by IARE. So thank you very much for listening me. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.